let's all welcome Mernal to the stage.
Thank you. Thanks a lot. Thank you, everyone. Thanks, Cody. All right, so my name is Mernal. I am CTO and co-founder at Autonomy. You can find us on autonomy.computer. So Cody touched on building agents, and a bunch of people have built agents, right? So my personal journey went something like this. You initially think about what an agent is, and as a programmer, you go, well, looks like a state machine that calls an LLM, right? That's the starting point. So, okay, cool. I can build a state machine that calls an LLM. Let me build one. That's kind of usually the starting point, right? So you get an API to call an LLM somewhere, right? And then you write that state machine. That's step one. Then you go, well, actually, I also need to do tool calls. I need to deal with prompts. That's a lot of work. Maybe I'll go look for a library that someone else has done some of this work, right? So you go get, I don't know, LangChain or something, right? Cool, progress, right? It starts to feel like an agent. It can call some tools. Next question becomes, well, where do I get the tools, right? So you have to think about what the tools are. Then you go, well, actually, I am building a product. I don't need one agent. I need one agent per user, right? So now I have to think about how do I deal with that problem. LangChain doesn't tackle that, right? Then you go, okay, actually, I've read a little bit online. Agents aren't very accurate if I just give them a big job, right? So I should break down my job into multiple little pieces, and I will write a few agents, and then I'll have these agents hand stuff off to each other, right? So then that creates another problem, which is, well, how do I hand things off? And you find some frameworks online. I think OpenAI has a handoff mechanism. Crew AI has a similar capability, right? So you go get one of those frameworks, and it can do handoffs. Okay, so now you've got this agentic app, and it looks very cool in a demo, right? You've built some UIs for it. Maybe you've written a little bit of API around it, right? And comes time to kind of take it into production. And that creates some challenges as well, right? So at least my experience was the following. I need the tools to exist where I'm calling them, right? I need a way to send messages between agents. Just doing it in one Python VM isn't sufficient. That's what Crew AI gives you, right? LangChain doesn't give you any mechanism to message. Crew AI gives you a messaging within one Python runtime. But I'm going to have many users and many agents. All these things need to send messages to each other. I need something more robust than just the Python VM sending little pub sub messages around, right? And I need long-term state, I need to save this state, etc. So you then start to think about, well, I'm just going to roll this all on my own, right? And so that's kind of been my journey, and that led to us building Autonomy. And Autonomy kind of takes all of these features that you need and gives them to you. So what is Autonomy? Autonomy is three things. It's a framework to write agents. It's a place in the cloud called the Autonomy Computer to run agents and the required tools around it. And it's a command line, the third piece, that allows you to take the code you write in your agent framework and deploy it to this command line and observe it and run evals, etc. So it's these three components, but these three components are unique compared to everything else you've seen out there. So hopefully through my next 10 or 11 minutes, I'll be able to show you some of these unique capabilities. Okay, so first thing I'm going to do is, if you go to this QR code, there is a demo prompt. And I encourage everyone here to copy that prompt and give it to your favorite coding agent, Claude Code or Cursor or whatever you like. And what that prompt is going to do is build an Autonomy app. And in the process, it'll sign you up for Autonomy and give you free credits to use it as well. I think if you sign up today, it's like $50 of free credits, which is plenty. Okay, so, and I'm going to do the same thing right now. So if you go to that QR code, you'll end up at this page. I'm going to copy this QR code, go to my coding agent here, which I really like Zed. And so I'm going to tell Zed to run this prompt, and I will then walk you all through what I'm doing. So I've hit enter, and I've told Zed to run this prompt. And what this prompt is saying is, hey, fetch the autonomy documentation from this URL and any relevant links, create a new autonomy app that news editors are going to use to fact check the news stories. They're going to take an article, drop it into a web form. An agent should break the article down into a collection of facts. And for each fact, I want you to conduct deep research on the internet and gather information about whether or not that fact is true or not. To do the research, you'll need an MCP tool, so go get that MCP tool as well. And oh, by the way, I don't know what the UI should look like. Can you just create one for me in Next.js and ShadCN? And when you're done, deploy the app and give me an architecture diagram. That's what the prompt is doing. And this thing's now already started working. We're not going to have time to wait for it, so I have a pre-recorded version of this that I will show you. Right, so it starts working. Initially, it throws an architecture diagram where it says, OK, I'm going to build a fast API backend for this thing with an API. I'm going to create a fact-checking agent, claims extraction agent, and then I'm going to break each claim and run parallel agents for each claim. Doesn't matter how many claims, could be 50 claims in an article, 5,000 claims in an article, doesn't matter. I'm going to run parallel agents to analyze and research each of those claims, right? And then about 10 or 11 minutes later, it says, OK, I am done. And it wrote all this code on the left in the process, right, which everyone here has used coding agents. It did all the right stuff. But it wrote code for the UI, and it wrote code for how to use autonomy and create fleets of agents, right? So you didn't have to learn how to do this, but you're able to create this distributed fleet of deep research agents. But now let's think about what a deep research agent needs. A deep research agent cannot work with the context window it has available from the model. So what happens is, as you try to write long-running agent, I'm sure some of you have experienced, context management becomes a really challenging thing. So in Autonomy is a baked set of tools around managing context. For example, we can give you a file system. So your agent now has a file system isolated to that specific user and to that specific scope or specific instance of the agent. And in that file system, research documents can be collected, memory can be collected, et cetera, right? So those primitives exist. Each agent in Autonomy is written as an actor, like Erlang actors or Scala actors, if you're familiar with that idea. It's a very, very lightweight concurrent entity, so you can run thousands of parallel agents in a tiny container using Autonomy. All these agents can message each other. And if you're running multiple containers, we automatically connect all the containers, and all the agents in all the distributed fleets of containers can message each other, right? That gives us this communication fabric to create lots of deep research agents. So if you have an app like this, where each article is required to be, it has 50 facts in it, and you have, let's say, 500 customers, at any point in time, you might be running thousands of parallel researching agents. And building that from scratch is complicated and will take many months. But here, the code is already written. And then I tell the coding agent, here's my Brave secret key for my MCP server. And about another 5-6 minutes later, it launches the app. The app is hosted in the cloud, ready to go. You can give it a custom domain name, and it's ready and live, right? And I ran this just before I came here. So here's an instance of this app. I gave it a dummy article about the moon landing with some fact mistakes. It created 18 plus 2, 20 parallel agents for me. Each agent then went and researched each individual extracted fact. and then created a report about that fact with links and references, et cetera, right? So it's able to do these like long-running tasks on its own, and you can do things like code generation. So you could build your own kind of distributed in the cloud Claude code-like experience if you wanted, right? Because these are deep work agents, and context management is handled in a very elegant way. Okay, so this one thing worked. I also want to, since I'm on the screen, want to show you that, in fact, this can run lots of agents. So this is the back end of a customer. So we have a customer that's a bank that receives phone calls and receives documents during the phone call from their customer. And based on those documents, they want to, in the phone call, decide whether or not to issue that business a loan or not. So each business gives them a few hundred documents. At any point in time, they have thousands of calls ongoing. So at any point in time, they need to run thousands of parallel or tens of thousands of parallel agents that research and decide whether or not to give this person a loan or not, right? So when I hit this button, we're going to spin up 5,000 parallel agents. They're all going to work on researching a single document. And so I spun up 5 parallel containers. They're all connected. They can collaborate. This is kind of like distributed agentic MapReduce, if you're familiar with MapReduce as an idea, right? But you didn't have to build all the underlying infrastructure. All the underlying fleets of containers, the connections between them, the messaging pipeline, everything is written for you already. All your code is doing is actually writing a YAML file that says, okay, give me one container, that's my kind of main orchestrator container. Give me 5 runner containers. Each runner container is just an empty code receiver. It just receives messages. And the main app is the code that your coding agent can generate for you. But I'll focus on just the for loop part of this. Somewhere here is a gather. So over here, you see run, analyze, gather. That's all it takes to create a loop of 5,000 distributed parallel collaborating agents, right? Okay. And our coding agent probably is doing its work. I lost my window, sorry. There you go. This thing's still working. I don't think it will finish in this time frame, but I have 2 minutes, so I'm going to show you one final demo, and then we'll call it. So like this, you can also build voice-based agents with the same experience. So you write a little prompt, and you say, give me a voice agent that does this. Here's an example of a voice agent that conducts interviews. And we have a customer that's doing this with recruitment agents that go out and conduct first-round interviews. So this is an example I generated. Hi, I'm a software engineer with 3 years of experience.
Great. Let's dive in. Can you briefly explain the difference between an abstract class and an interface in Java?
No, I don't really want to do an interview in front of 100 people.
No worries. This is just a one-on-one chat. So about those Java
Okay, so it works. But think about what you have to do to build a voice agent. It's not just the voice model. Yes, you need that. But it's also streaming infrastructure to support thousands of parallel voice streams going and serving all your customers. That is hard, complex engineering, and with Autonomy, we just take care of all of that for you. So you just get a WebSocket client that you can stream to your UI. You can even build this UI. I didn't build it. It just got generated for me, right? So that's what Autonomy is. I'll stop here. It's a framework to build agents that has unique features like actors, collaboration, context management, the ability to spin up sub-agents and fleets of sub-agents. Plus, it is a runtime environment in the cloud that can run all your tools. It can run distributed containers and connect them all, so you can run fleets of distributed, kind of MapReduce-like agentic fleets. And it can even connect to private enterprise data sources over private links. And then finally, there's a command line that helps you do all of this. So thank you all.
We can do one question. Actually, two, because I have one. What was the craziest custom URL somebody's made with you?
Oh, crazy. People are doing professional stuff with her. So they're making like their business domain, so nothing crazy. Yeah.
I just wanted to ask, like, what's the pricing on every query? You ran like an example. Did you pay like $20 to run that?
No, I didn't. So that's the cool thing, right? So because I can run these parallel containers, the first question is, what's the compute? And the naive way to do this is to try and spin up thousands of parallel lambdas and try to run them for a long period of time. And if you've ever tried to, one, spin up thousands of parallel lambdas, it becomes very hard because you hit all sorts of quotas with AWS. Two, if you've tried to run them for a long period of time, which is what an agent needs to do, you hit all sorts of, like, AWS will kick you out and kill your containers. So it becomes very hard. It's a naive architecture. Plus, you need to spin up some messaging thing. In Autonomy, none of that happens. Because Autonomy agents are actors, in that particular example, I spun up 5 250 megabyte containers, and each of them ran about 1,000 parallel agents, right? So it's very, very cheap to spin up the agents. Second part of this is the cost of talking to the LLM itself. That depends heavily on the task. But turns out, for a lot of agentic analysis, really cheap models on Amazon that we do provide are very good. Like, I think in that particular example, we're running the Nova model, which is 10,000 times cheaper than Claude, but is successful because we're able to eval and check the results. So by creating parallel fleets, you're able to keep the scope of the analysis very, very small, which helps with keeping the context very, very small, and which helps a small model succeed. And this model just works a lot better than trying to give a lot of context to a big model and spending a lot of time and money.
So I do all this just to get my cost down. And then if I make a comparative...
Cost and accuracy up.
I see. So have you done any analysis on the accuracy?
Yes, we run evals with all our customers for their very specific use cases. And in all of those cases, they're able to sort of tune accuracy up.
Great. Thank you.
Thank you all.